This is R.D. Sharma's solution. Chapter is probability and exercise is the third exercise. Two dice are thrown. Find the probability that the numbers appeared has the sum 8 if it is known that the second die always exhibits 4. Now die you already know. So we are talking about two dice here. A die has 6 faces marked from 1 to 6. So first one can give you 1 to 6. Second one also can give you 1 to 6. So there are two dice, there are 6 possibilities, so 6 raised to 36 is the sample space. That is all the combination which are possible of number 1 to 6 for both the dice are 36. Find the probability. Now probability is A by B. Now this time we'll do a reverse. That is to make you understand that both the things are okay if it is being presented or shown to you, or if you write like this. The probability which is below has already happened and above is to be found out. So A, we will mark an event that 4 appears on second dice. So number appeared has the sum 8. Now this is what we need to find out. A has already happened. Second die always exhibits 4, always turns out to be 4 is A. Now B is the number has appeared 8. So number appeared has sum 8. Now let's make the events and elements. Now 4 is fixed in the first case. 4 appear in the second die. First can come from 1 to 6. But the second is fixed. So the first can come as 1, 2. So I am fixing the last one, the second die. The first can be 1, 2. Then 3 can come, 4 can come, 5 can come, 6 can come. So this is the event A, or all the experiments which you see for event A. Now what is the number of elements in A? A 1, 2, 3, 4, 5, 6. So it is 6. Coming to B, now probability of B by A, the numerator remains the same for B by A or A by B. This is number of elements in A intersection B divided by number of elements in A. So the number of elements in B will not be required, but A and B intersection is required. That's why we have to write the event B and the set values. So B is number appeared has sum 8. So 4 give you 8, 3 5 give you 8, then 5 3, then 2 6 and 6 2. So 4 can come in both of them, but this set has the property that the redundancy cannot be there. So only 1 4 will come. Now what is A intersection B? A intersection B means we have to find out those elements which are common in A and B, which are found both in A and B. So 4 is fixed in first case for the second die. So only this 4 can be taken, or this value is the only common value between A and B. So only one element is there. Now the formula is what? NA intersection B divided by NA. NA intersection B is 1. And what is NA? Number of elements in A? It's 6. So 1 by 6. So probability of event B when A has happened is 1 by 6. Now this is how this will be done. A pair of dice is thrown. Find the probability of getting 7 as the sum if it is known that the second die always exhibits an odd number. So we'll do B by A here. That we'll make A and B just now, but let me reiterate the formula or the equation. PA intersection B divided by PA. So we need number of element in A intersection B, number of element in A. So what is A here? A has already happened. So if it is known means it has already happened. The second die always exhibits an odd number. So I'm writing it in short. A we can write it as number appeared on second die is odd number. So what are the odd numbers? See, there are 6 possibilities and in all there are 2 dice. So 36 is the sample space. And in this sample space, those numbers which are odd 1, 3, 5. So this is about the second die. So 1, 3, 5 can come as the second number. But the first can be 1, 1, 1, 1, 1, 1, 3, 1, 5 is a combination. Then 2, 2, 2, 2, 1, 2, 3, 2, 5. 3 1 3 3 3 5, 4 1 4 3 4 5, 5 1 5 3 5 5, and likewise we go up till 6. So I'm writing it now. So 1 1 1 3 1 5, 2 1 2 3 2 5, 3 1 3 3 3 5, 4 1 4 3 4 5, 1 3 5 is fixed for the second die. I'm just changing the numbers 1 till 6. So 5 1 5 3 5 5 and 6 1 6 3 6 5. So this is how you have to write, and all of these experiments in this event are elements which has to be inside the round brackets, and they need to be separated by comma in between them. That's the essential part of doing this. Now this NA is what? Number of element in A. So there will be half even, half odd. 36 are there. Just half it, 18 will come. The number of element in A, if you count it also, it will come as 18. Now you don't need to find out NB, but this set B needs to be found out because we need A intersection B, the elements which are common in A and B. Now the probability of getting 7 as the sum is the B set. So first 2, then 5, then 5 and 2, then 3 and 4, then 4 and 3, 1 and 6, 6 and 1. So all these which you see inside the brackets, the sum will be 7. So they are making 7, and since both the die we are taking care, so anyone can have certain numbers and that can be reversed also to get a 7. Now A intersection B is what? The common values between A and B. The A has only 1, 3, 5 at the end. So this 2 and 4 cannot come. 1, 6 cannot come. All the odd number which are the second die in B cannot come. So 2, 5, 4, 3 and 6, 1. These are the elements you will find both in A as well as B. So number of element in A intersection B is 3. Just count them. So the formula we have written earlier, P intersection B is 3 or NA intersection B is 3 and NA, number of elements in A is 18. So 1 by 6. PB by A is what? 1 by 6. That is your result. Now this is how you need to write it, and the two die, the proper combination and the sample spaces, if you are aware, then this question will be quite easy for you. So the common values are this and the required probability is this. A pair of dice is thrown. Find the probability of getting 7 as the sum if it is known that the second die always exhibits a prime number. Now we have two die and these are being thrown or tossed. Now this 7 should come as the sum. So we'll make two events. B is sum of numbers on two dice. So this is 7. When you add the values which come up in two dice, it should be 7. So 2, 5, 5, 2, 6, 1, 1, 6, 4, 3, 3, 4 will come. If it is known, that is this is already happened or it is known probability that the second die always exhibits a prime number. So prime number is what? 2, then 3 and 5. So let me write it officially. Prime numbers are those numbers which are divisible by either themselves or no other. So in this, 2 also, you will say 2 divides itself and 2 is an even number. No, 2 has a separate explanation for that. But you know that 2 is a prime number. 3 is a prime number. 5 is a prime number. So odd numbers are not always prime numbers. This has to be known very clearly. Like if you take 15, 15 is not a prime number because it is divisible by 3 as well as 5. Numbers which cannot be divided by any other number, like 19, like 17. So set B, this is sum of numbers on two dice is 7. We have just done it, means a question like this. Let's make A first. Second die is exhibiting a prime number. Either it can be 2 or 3 or 5. So 2, 3, 5. Write it 6 times. Why I'm saying it? Write 6 times. Because first time 1, 1, 1 can come. 2, 2, 2. Then all this 2, 3, 5 you can write it 6 times. Because this is going to come in this second die. The first die can have 1, can have 2, can have 3, 4, 5 and then 6. So this is why I have written like this in a matrix form, because the counting becomes easy. If you write it in just one line, the counting may be a problem. So just see that there are 3 and 3 columns and 6 rows. So 6 3s are 18. Number of elements in A is 18 now. Now sum of numbers on two dice is 7. 7 means 1 6 6 1 and 5 2 2 5 4 3 3 4. So this all combination means first and second die number being added should come up as 7. So 2 5 5 2 3 4 4 3 and 1 6 6 1. So these all has come here. You don't need to find out NB because it is not required as per the question. PB by A formula says that it has to be NA intersection B divided by NB. NA, sorry, not NA, it will be. NA intersection B already found out 18. The number of elements which are common in both of them. So we are now trying to find out A intersection B. And please remember only 2, 3, 5 can come in the end. So 2, 5 is a common number. 5, 2 is a common number between these two. 4, 3 can come. 4, 3. The others will not come. You will see that only these are common. So number of element in A intersection B has come as 2, 5, 5, 2 and 4, 3. So these are 3 numbers. So 3 by 18, 1 by 6 is the correct answer. So this is how you can write it whenever you are writing it. And you can take a reference from here also. A die is rolled. So we are talking about just one die. If the outcome is an odd number, what is the probability that it is a prime number? Let's make the event. So we have A and B. A is that number is odd. B is number is prime. Now we are writing the formula now, PB by A. Now when it is known that if A has already happened, what is the probability of getting B? That is why if it is known that the number is odd, what is the probability that the number is prime? So PA intersection B or PB intersection A divided by number of elements in A or probability of A. Let's make the set now. A's number is odd. So in a die 1, 2, 3, 4, 5, 6. All these 6 numbers can appear on the face up. What are the odd numbers? 1, 3 and 5. These are the odd numbers. The number of elements in A is 1, 3, 5. So 3. In the B set, it is number has to be a prime number. So 2, 3, 5 are the prime numbers. You don't need to find out the number of elements in B. A intersection B has to be computed. What are the elements which are common in A and B? 3, 5, 3, 5. So 3 and 5 are the common numbers between A and B. Number of elements in A intersection B is 3 and 5. So these are 2 numbers. So let's write it in the formula. Number of element in A intersection B is 2, probability of A and A is 3. 2 by 3 is the correct answer. So the 2 by 3 is a high probability. Now this is how it has to be written. Now this question will be done in the later part. Thank you so much. Have a good one.